Friends, welcome to another series of iCamp lessons. Today we'll be continuing with our part 2 of the practice paper. I think it's a paper from Limpopo. It's a very good practice, especially in preparation for your June exams. So let's look at what we have today. So we have question 5. And they are telling us that OABC is a parallelogram where O is the origin. So O, we have O here. And A lies on the y-axis, as we can see here. A is on the x and A is on the y-axis. BOC, so this is BOC, this angle is 39.23, correct to two decimal places. BC and X are collinear, right? And X lies on the x-axis. So let's make that practical. So BC and X, right, are collinear, and we know about collinear lines. So if something is collinear, if they say the points are collinear, that means that those points lie on the same line, right? So B, C, and X should lie on the same line. So we are just going to construct a line, and then we are going to call this point X, right? And then we still have C here. So now B, C, and X are collinear, and X does lie on the x-axis, right? So now let's look at how we can find 5.1. So we have 5.1, right? So 5.1, they are saying find the coordinates of M, right? The point where the diagonals of the parallelogram intersect, right? So it's this point, right? Which is the midpoint of OB and the midpoint of OAC, right? It's the midpoint of OB or the midpoint of AC, right? So usually on these type of problems, you use what you have, right? So O, which is the origin of the circle, which is the origin here, it means that O is going to be 0 paired with 0, right? So we are going to use B and O, right, to find the midpoint, which is M, right? And we are going to use the midpoint theorem to do that, right? So let's go ahead and do that, right? So we are going to use the midpoint formula, which is x1 plus x2 all over 2, y1 plus y2 all over 2, right? And remember what we are using. We are going to use BO as points, right? So you need 2 points here. So B, remember B, so our B, the coordinates of B is going to be 4 paired with 7, and the coordinates of O is just 0 paired with 0, right? It's 0 paired with 0, and this can be your x1, this can be your x1, x1, y1, right? And this can be your x2, y2, right? So now let's go ahead and substitute. So you have M, which is equals to, what is your x1? Your x1 is 4 plus 0 over 2, and you have y1, which is going to be 7 plus 0 all over 2, and then your midpoint is going to be 4 plus 0 is 4 divided by 2 is going to be 2, and then 7 plus 0 is 7 divided by 2 is going to give you 3,5. So these are your coordinates of the midpoint, right? These are the coordinates of your midpoint. Perfect. Now let's look at 5.2, right? So 5.2, they are saying calculate BOX, right? So calculate BOX, right? So we have to construct or see where BOX is. So BOX is going to be this angle. So we have BOX, right? So BOX, it's going to be this angle, right? So it's going to be this angle, and we can call it just angle theta, right? So what I'm going to do is I'm going to construct, or I'm going to take this as a triangle, as one triangle, right? So this is going to be my triangle, right? I'm going to take BOX, right, as a triangle, right? So now I'm going to say in triangle BOX, right? Remember, what do I want? I want BOX. I want that angle, right? So what I'm going to do is I can just construct, I can just put this triangle here, right? And then here it's just going to be theta, and then it's going to be B and O and X, right? So from this triangle I have B. So B, so the distance from here, right, from here to here, it's going to be 7 units, right? Because we are looking at your y-axis. So the point Y, which is 7, it's going to be 7 units. So that means that this point here, it's going to be 7, right? And then from O to X, it's going to be 4 units, right? Which is going to be 4 units. So now, what do I have? So now, remember, this is going to be a right angle triangle. So remember, what do I see now? So now I have a right angle triangle, which means I can apply my trigonometric functions, right? So in this case, right, I have your opposite, right? I have your opposite, which is this side. So the side opposite to an angle is going to be your opposite, right? You can just call it O. And then the side next to your angle is going to be what? Your adjacent, right? So what happens if you have opposite and an adjacent? You can always use tan, right? So now you can just say tan theta is going to be your opposite over adjacent, right? And then now you have your tan of theta is going to be, what is your opposite? Your opposite side is 7, and then your adjacent side is what? Is 4, right? And then now you can do your tan inverse. So it's going to be, theta is going to be your tan inverse 7 over 4, right? And then now your theta is going to be, so what answer do you get when you punch your calculator? If you say tan 7 over 4, right, you should get 60.25. Is it 60 yeah, 60.25. So we are going to round off to 2 decimal places. So this is going to be 60.26 degrees, right? So therefore angle BOX is going to be 60.26, not 62, it's 26 degrees, right? Perfect. So now we have our BOX, right? We have our BOX, which means that the entire angle there is going to be 60.26. Right, so now let's look at 5.3, right? Let's look at 5.3. Right, so 5.3, they are saying determine the gradient of AB, right? So let's look at 5.3, right? Determine the gradient of AB, right? Remember, ABCO, right? We were told that OABC is a parallelogram. And what do we know about two opposite sides of a parallelogram? They are parallel, right? So that means that your AB is going to be parallel to what? To OC. So this means that both these are going to be parallel to each other, right? So your AB is going to be parallel to OC. Why? The reason is very simple. Your OABC is a parallelogram, right? OABC is a parallelogram, Right. And what do we know about the gradients if the gradients of lines that are parallel to each other? Right. So it means that the gradient is going to be equal. Right. So that means that the gradient, right, the gradient of AB is going to be equals to the gradient of OC. Right, and we'll see why that is very important, right? The reason why that is important is because if we look at AB, we don't know the coordinates of A, right? So we cannot use our normal gradient formula, right? However, we do know the coordinates of O, but we don't know the coordinates of C, right? And if we don't know the coordinates of C, that means that we still can't use our gradient formula. So that means that we have to use angles to find the gradient, right? And the most or the simplest equation that we can use to find the gradient using an angle is your tan theta is going to be equals to m, right? So now remember, we want the gradient of OC, right? So we want the gradient of OC, this line, right? So if we have the gradient of OC, that means we also have the gradient of AB, because they are parallel to each other, right? So in order for us to do that, we are gonna need to find this angle, right? We're going to need to find this angle, which is an angle I'm going to call alpha, right? But remember, we do have theta, which is this entire angle. And we said theta is equals to, so we said theta is equals to 60.26 degrees, if I'm not mistaken. Yeah, it's 60.26, right? So we need alpha, right? So we need alpha, right? So remember, your theta is going to be alpha plus 39.23, right? Why are we saying theta? Remember, theta is this entire angle, right? So remember, theta is this entire angle. Great. So what is theta? Theta is 60. It's 60.26 equals to alpha plus 39.23. We want alpha, right? So alpha is going to be 60.26 minus 39.23 degrees, right? So alpha is going to be, when you punch your calculator, this should give you 21.30. So when you punch your calculator, 60.26 minus 39.23, right, it should give you, in fact, it should be 0.3 degrees, right? This is 21. Great. So now we have alpha, right? We have alpha. So alpha is this angle, right? So alpha is this angle from here to there, right? Now it's gonna be easy for us to find the tangent, the gradient of OC, right? Because now we can simply say that your tangent of alpha is going to be your gradient of MOC, right? And then the tangent of alpha is going to be 21.03, which is going to give us your gradient of MOC, right? And then the gradient of OC is going to be your tangent, which is literally the same thing written in opposite, 0.3. And then if you punch your calculator, what is the tangent? What is your tangent of 21.03, right? That should give you 0.38. 0.38. That's your tangent, right? Therefore, the tangent of OC is going to be equals to the tangent of, not the tangent, the gradient. It's going to be the gradient of the gradient of OC is going to be equal to the gradient of AB, right, which is equals to 0.38, right? It's going to be equals to 0.38, and therefore that's going to be your answer, right? So now let's look at 5.4, right? So now let's look at 5.4. So in 5.4, they are saying determine, right? Determine the coordinates of C, right? Determine the coordinates of C, right? So remember what we have here. Here we had constructed a line which we called X, right? So if we want to determine the coordinates of of C, the first thing, right, the first thing that's gonna come to my mind, right, is that C will have the same X value as B. Why? Because remember we were told that B, C, and X are collinear, right? So B, C, and X are collinear, right? Meaning that they will have the same X value, right? They will have the same X value, right? Meaning that they will have the same X value, right? So that means that your X of C, right, the coordinates of your X of C is going to be what? Is going to be 4, right? Why? Because remember, your X value is 4. That means that going throughout, it's going to be 4. Great. So now we need to find y. So already that means that we have 4 here, and we also have y of c, right? So remember what we have. We do have this line. We do have the gradient of this line, right? We do have the gradient of this line, right? So it becomes easy if we have the gradient of that line, because we can simply say that the gradient of OC is going to be your y of C minus your y of O all over your x of C minus your x of O, right? What is the gradient of MOC? It was 0.38. What is y of C? That's what we are looking for. What is y of O? It's going to be 0. Why is it 0? Because it's O is the origin. And then what is x of C? X of C is 4 minus 0, right? So now you have 0.38 equals to your y of C all over your 4, right? So your y of C, if you multiply by 4 both sides, multiply by 4 both sides, this and that will cancel, and then you will have y of C as 4 times 0.38, and then your y of C is going to be, what is 4 times 0.38? 4 times 0.38, it's going to give you 1.52. 1.52. So that will be your answer, right? And therefore, what you can say is that, therefore, the coordinate of C, it's going to be your 4 paired with 1.52, right? So that will be your coordinates. Great. Yeah, don't mind these double ticks. They are not for mark purposes. I'm just putting them out there as part of just saying we have the answers, right? So now we've found the coordinates of C, right? We have found the coordinates of C. Maybe alternatively, what you could have done, right? Alternatively, what you could have done, remember there are so many ways of killing a cat. So maybe let's just do an alternatively. Right, so this is what we could have done. So let's just copy the same, and we take it to the other side and we try to solve it, right? So I'm just trying to show you another way we could have solved this. Perfect. So now, alternatively, in order for us to find the coordinates of OC, remember what do we have? We do have the gradient of, so this is 5.4 alternatively, right? This is 5.4 alternatively. So in order for us to find that, remember we do have the gradient of OC, which was 0.38, right? And OC is a straight line passing through the origin, as we can see there. So it means that you are going to have y is equal to mx plus c, and then your y is going to be 0.38x plus c. Right, so c, it means that it's going to be a 0 because why? This is a straight line passing through the origin, right? So it means that our equation is going to be y is equal to 0.38x, right? So maybe we can just note here, passing origin. Right, so now you have y is equal to 3x. You have 3x plus, y is equal to 0.38 times x. Right, so if you have y is equal to 0.38x, remember we did have your x of c. Your x of c was equals to 4. Right, in order for us to find y, we are just going to substitute we are just going to substitute x of c into here, right? And then this is going to be y is equal to 0.38 times 4. So your y is going to be the same thing that we got here, which is 1.52, right? So it's going to be 1.52. And then you can just write here that your c, the coordinates of c, is just going to be 4 and 1.52, right? So this is another way in which you could have solved this, right? So now let's look at 5.5, right? So in order for us to find the coordinates of A, we are just going to start here, right? So remember, A is an y-intercept, right? A is y-intercept, right? So what does that tell us about the x value? So anything that is y-int, right? So let's just write it is y-intercept, right? So for y-intercept, right, x is equals to 0, right? So therefore that means that your x of A is going to be equals to 0. So we have one value, right? Remember, we want the coordinates of A. Great. So we have a point, right? So this is what we are looking at right now, right? So we are looking at this line, right? Remember, what did we say? We said that the gradient of OC is equals to the gradient of AB, which is equals to 0.38. Why? Because your AB is parallel to OC, right? So that means that you have your MAB equals to 0.38. Let's go, right? So remember, AB is a straight line, right? So AB is a straight line, AB is a straight line passing through, is a straight line which passing through A, right? So it's going to take the form of y is equals to mx plus c. And remember, we do have the gradient, so it's going to be y is equals to 0.38x plus c. Right, so in order for us to find the value of c, we are going to use b. Right, so we are going to use b, which is 4 and 7, right? So now we are going to have 7 is equals to 0.38x, not x, it's going to be 4 plus c. So we are going to have 7 minus 0.38 times 4, which is going to give us c. So the value of c that we get here is going to be your y of a. Why? Because it's an x-intercept. I mean, it's a y-intercept. It's where the graph passes through. So if you say 7 minus 0.38 times 4, that should give you 5.48. Right. So c is going to be 5.48. Right. So therefore, you are going to say your y of a is going to be your 5.48, and this is going to be your coordinates. So your coordinates is going to be 0 and 5.48. So the reason why we say c is going to be y of a, because this is where the graph passes. It passes through this point, right? Great. So now we have solved question 5. So now let's move on to question 6. Right, so in question 6, let's come here. So in question 6, right? So in question 6, they are saying in the diagram below, the straight line SP is drawn having S and P as its x and y intercepts respectively. So x is going to be, S is going to be your x-intercept, and then your your P is going to be your y-intercept respectively. The equation of SP is, then we are being told that equation, this is the equation where a is greater than 0. That's a condition. That means that if in any case in the question we are being asked to find a should be greater than 0, because they already set out that condition for us. It is also given that OS, right? So OS is thrice OP, right? So OS is 3 times OP. Great. The straight line RT is drawn with R and with R on SP, right, as we can see. And RT is perpendicular to PS. RT cuts the y-axis at 0 paired with -5, 2/3. Great. So now they are saying calculate the coordinates of P, right? So we are gonna go ahead and calculate the coordinates of P. So what is P there? The first thing that should come to our mind, right? What is P? P is y-int, right? And what do we know about y-int? So for y-int, right, so for y-int, x should be equals to 0. Right, so it means that your x of P is going to be equals to 0, right? So that means that your x of P is going to be equals to 0 already. Great. And remember, we do have the equation there. So you have an equation which is x plus ay minus a is going to be equals to 0, right? So we do have x already. X is 0, so you are going to substitute it, right? It's going to be 0 plus ay minus a is equals to 0. So now you are going to be left with ay minus a is equals to 0 equals to, and then we can just transpose your ay is equals to a, and then you divide by a, right? And then this and that will cancel, this and that, 1 times, and then you are going to be left with y equals to 1, right? So you have y is equals to 1. You also have your x equals to 0. Therefore, the coordinates of P is going to be 0 paired with 1, right? So those will be your coordinates. Great. So now let's look at 6.2, right? 6.2, they are saying calculate the value of A, right? So we need to calculate the value of A. So now we are going to use S. Remember, we've already used P. So now let's use S, right? So the idea is to find the value of A, right? So now we are going to use S. Remember, what is S? So S is an x-intercept. So S is x-intercept. And what do we know about x-int, right? So for x-int, your y is going to be equals to 0, right? Your y is going to be equals to 0. So let's try to write this neatly. So S is x-int, right? And for x-int, your y is going to be 0, right? And then now we are going to write out our equation, right? So our equation is x plus ay minus a is equals to 0. Remember, we have y is equals to 0, so it's going to be x. It's going to be x plus a into 0 minus a is equals to 0. So your x now, the value of x is going to be, remember, this and that will cancel. So you are going to have x minus a, and when you transpose a, it's going to be positive a, right? So we still have x equals to a, right? So therefore, it means that your S, right? It means that your S is going to be a paired with 0, right? A paired with 0. So why is this important? This is important because it means that this length here, it's going to be 4, right? Because from here to here, it's 4. No, it's not 4. I mean, it's A units, right? It's going to be A units. I don't know why I'm saying it's 4. Yeah, your OS is going to be A, right? So that means that your OS is going to be A, right? Because the value of x at A, right? The value of x at A, the value of the value of x at S is A. So here you have A paired with 0, right? So hence that is 0. That is A, right? So remember, we have this relationship that says, remember, we have this relationship that says OS is equals to 3 OP. Great. So now we have OS as A, then we need OP. Right, so OP, remember what we found. We found P to be 0 and 1. Right, so that means that this length here, from here to here, it's going to be 1 unit. Right, so from here to here, so this is just going to be 1. Right, so we can just write it. So it's going to be 1. So that means that OP, is going to be 1 unit. Right, and therefore this suggests that now what we have A equals to 3, right, times what is OP? 1. Right, so this is just going to be 3. So that means that your A is going to be what? 3 units. Right, so we can just say your A is just going to be 3 units. Right, and then you have your answer. This is your answer. Great. So now let's look at 6.3. So in 6.3, they are saying determine the equation of RT, right? Determine the equation of RT. So this line, right? Determine the equation of RT in the form of y is equals to mx plus c if it is given that a is equals to 3. Right, so if it is given that a is equals to 3, so that's what we are going to start with, right? So where is a applicable? A is applicable in this equation, right? So we are just going to say 6.3, right? A is equals to 3, and we also found that out, right? So x plus ay minus a is equals to 0. So what we are just going to do is substitute a. So x, so this is going to be x plus 3y minus a is equals to, minus 3 is equals to 0. And then we try and write this properly. So it's going to be x plus 3y minus 3 equals to 0. So we can just make y be the subject of the formula. Because we are dealing with a straight line here, we are trying to write it in the form of y is equals to mx plus c. So we are going to have 3y is equals to x plus 3. Then we divide by 3, divide by 3. So this and that will cancel. So we are going to be left with y is equals to, this is going to be 1 over 3x. So y is going to be equals to 1 over 3x plus 1, right? So this is the equation of SP. This is the equation of SP, right? Remember, what do we know, right? What do we know about SP and RT, right? So SP and RT are perpendicular to each other, right? So SP is perpendicular to what? Is perpendicular to RT, right? And what can we say about their gradients, right? What can we say about their gradients, right? So what can we say about the gradient of perpendicular lines, right? What can we say about the gradient of perpendicular lines? So the gradient of perpendicular lines, right, it's going to be the product of perpendicular lines, right? The product of gradients of perpendicular lines is always equals to -1. So what do we mean by that? So the gradient of the gradient of SP multiplied by the gradient of RT should be equals to -1. So the product of these gradients should give us -1. Why? Because your SP is perpendicular to RT. Is perpendicular to RT, right? So already we have the gradient of SP. So this is the gradient of SP, right? So this is the gradient of SP, right? So the gradient of SP, so your M of SP is equals to 1/3, right? So in order for us to get -1, it means that your M of RT, the gradient of RT, should be the inverse of this with a negative sign, right? So that means that your M of RT will be the inverse of 1/3, and the inverse of 1/3 is 3, so it's going to be -3, right? So if you take the product of 1/3 and -3, it should give you what? -1, right? So already it means that we have the gradient, right? And if we have the gradient, and we know that MRT is equals to 3 units, right? Your MRT is equals to 3 units. That means that you have now your y is equals to -3x plus c, right? And then from here we can simply use what? We can simply use t, right? So from here we can simply use t to find your x-intercept, right? To find your c. But however, which is very important, remember here it's t, right? So that means that your -5 times 2/3, it's going to be the value of c. Why? Because it's your y-intercept, right? It's your y-intercept. So that means that your c is going to be, if you do this in simple terms, so your -5 times 3, it's going to be 15 plus 2, it's going to be 17. So this is going to be -17/3. So that's your c. So your c is going to be -17/3. And then therefore you have your equation, right? Therefore you will have your equation, and your equation will then be represented by y is equals to -3x minus 17/3. Right, perfect. So we can just take this a little bit here, right? Right, great. So the reason why we say c is going to be -17/3, it's because already t is a point on y-axis, and RT passes through t, and the y of t will be the intercept, which is the y-intercept, where the graph will pass through of RT. And therefore this is how we find 6.3. So now let's look at how we can find 6.4. Let's go to 6.4. Perfect. So in 6.4, they are saying calculate the coordinates of R, the point where P, S, and TR meet. Right. So this is very simple. This is where the points meet. Right. So that means that we are going to substitute the equation. We are going to equate the equation of SP and RT. Right. It's gonna be simple. So if you have, so it's going to be 6.4. So your SP, right? So the equation of SP was what? It was y is equals to 1/3x plus 1, It was y is equals to 1 over 3x plus 1, right? And then your TR, it's gonna be y is equals to negative 3x minus 17 over 3, right? Let's do this. Okay. Perfect. So these are our two equations, right? So this, we can just call it equation 1, and this is going to be equation 2. So the point where these graphs meet, that's going to be R, and we are going to substitute y and y. So this now, it's going to be, now we substitute, or we equate, right? We are going to equate equation 1 and 2, right? So now you are going to have 1 over 3x plus 1 is equals to negative 3x minus 17 over 3, right? So what we can do here, we can just multiply by 3 to cancel the fractions, multiply by 3 both sides. So this and that will cancel, so we are going to be left with x, and then 3 times 1, it's going to be 3, and then this now it's going to be negative 9x, right? Negative 9x, and then this is going to be negative 17, right? So now you have x plus 9x is equals to negative 17 minus 3. So this is going to be 10x, negative 17 minus minus 3, it's going to be minus 20, divided by 10 both sides, and then this and that will cancel, and then you will have x is equals to negative 2. Oh, that's interesting. Why are we having x as negative 2? Did we do something wrong? Let's just check, because we are not supposed to have a negative 2 answer, right? We are not supposed to have a negative 2 answer, so it means we may have made a mistake somewhere. So let's just check here. Let's just check here. Let me check here quickly. Okay, minus. Okay. So here we are getting 2 as negative, but we know that 2 is not supposed to be negative, right? We are not going to be penalized for having negative 2 as an answer here, unless we do specify that x at r should be positive. So we are just going to change it and make it be positive 2, right? Yeah. So that's how we are going to go on with this. So x, here x should be greater than 0. So therefore we are going to say x is equals to 2, right? And then from here we can just substitute, right? So from here we can just substitute. I'm just gonna confirm before I move on to another question that we did not make a mistake, right? So now we are just going to substitute in one of the equations. So it's going to be y is equals to 1 over 3x. So this could be tricky. So now we are going to substitute negative 2, right? No, we should substitute 2 plus 1. So our answer is going to be, if we do that, so it's going to be 1 over 3 times 2 plus 1. 1 over 3. So 1 over 3. So punching 1 over 3 times 2 plus 1. I am getting, should be 5 over 3, right? I'm getting y as 5 over 3. So this could be incorrect. So I just need to check and confirm where I may have made a mistake. So let's see. We really need to confirm this, otherwise we are going to have issues. So here, okay, 3y minus 3, okay, and then when we subtranspose, it's going to be, yes, so this is where we may have made a mistake. This is where we made a mistake. This is where we made a mistake. This is where we made a mistake. So that's why it's always important to check. So here, when we transpose x, right? When I transpose x, as you can see here, it's positive. When I transpose x and it comes to this side, it was supposed to be negative, right? So this should have been negative 1 over 3x, right? Plus 1, right? Negative 1 over 3x plus 1, because when we transpose this, it becomes what? Positive. So that means that here it was supposed to be negative, right? And then this was supposed to be positive. And then from here, this would have been 3x minus 17 over 3. Yeah, 3x minus 17 over 3, right? And then even here, it was supposed to be negative, and then this should have been 3x. And then from here, this should have been negative, and this should have been positive, right? So we're gonna have negative x, right? And this was gonna be positive, negative x, and then this was gonna be minus 9, so this was gonna be minus 10. Yeah, and then from here, this was gonna be negative, and then this was gonna be positive 2, right? And then now you have x as positive, right? And then now you can just use negative, right? So you can just say, okay, the easiest one is really using 3x plus, no, it's the same thing in fact. So let's just negative 3 into 2 plus 1. So this was gonna be, so your answer here, if you punch your calculator, it was gonna give you 1 over 3, right? So this is why it's always important to check. Great. So now let's look at question 7, right? For those that noticed, thank you. If you did not notice, it's also okay, because at least we did manage to see where we made a mistake. So let's look at question 7 now. So let's look at question 7, right? So in question 7, we are being told that in the diagram below, O is the center of the bigger circle, right? So O is the center of this circle, right? This is the bigger circle. And the smaller circle passes through O. right? So let's read that again. So in the diagram below, O is the center of the bigger circle and the smaller circle passes through O, right? So you have a bigger circle, right? So you have a bigger circle. This is the bigger circle, right? So you have a bigger circle with center O, right? However, the smaller circle passes through O, right? Great. So PAT is a common tangent, as we can see here, to both circles. AC intersects the smaller circle, right? AC intersects the smaller circle at B, and OA is produced. And meets the bigger circle at D, right? So DC and OB are drawn. So DC and OB will be your chords, right? So there's things that I need you to note here, right? So OA, right? OA will be the diameter of what? Of the smaller circle. And then AD will be the diameter of the bigger circle, right? Great. So now let's go on to trying to prove this, right? So we are dealing with 7.1. So in 7.1 they are saying that we must prove that OB, this is line OB, so this is OB, is parallel to DC, right? So remember, in order for us, or in order for lines to be parallel, so we can write this. So in order for OB to be parallel to DC, right? So the first condition is that they are corresponding. So their corresponding angles should be equal, and the other condition is that they alternate angles should be equal as well, right? So in this case, I'm going to choose what? I'm going to choose the first one, right? I'm going to choose the first one, which is this one, right? Because here I don't see how I can find alternate angles, right? So remember, your corresponding angles are usually given by your corresponding angles is something looking like this, right? This will be your angle, and this will be your angle, and then your alternate angles, remember, let's just draw this here, right? So this will be your corresponding angles, right? This is corresponding, right? And then this will be your alternate, right? So hence I'm going to choose what? I'm going to choose this one, right? So what I want to do is I need to prove that the corresponding angles in this triangle are going to be equal, right? So what I'm going to do is I'm going to look at the smaller circle, right? So I'm going to look at the smaller circle. So this will be the smaller circle that I'm talking about, right? And then my bigger circle will be made. So this will be my bigger circle, right? So now, remember we said OA is a diameter. So that means that angle B1 is going to be equals to 90 degrees. right? So your angle B1 is going to be 90 degrees Y. It's going to be angles on semicircle, right? And then when we look at the bigger circle, your angle C, right? So yeah, this angle is going to be 90 degrees. And then now when you look at the bigger circle, remember OD is a diameter, which means that it divides the bigger circle into two halves. So that means that your angle C, right, this angle is also going to be 90 degrees. So your angle C is going to be 90 degrees, and we are going to have the same reason, right? Angles on semicircle, right? So therefore, that means that your angle B1 is equals to your angle C, your angle C, which means that these are corresponding, right? So they form an A shape, corresponding, right? And therefore we can conclude that your OB is indeed perpendicular to DC. Why? Because your corresponding angles are equal, which is B1 is equals to C equals to 90 degrees. Right, so now we can just end it here. Right, so we can just end it here. So now let's look at your question 7.2. So I think we just need to copy this. And paste it here so that we don't keep on coming and going back. So let's just take this up a bit. Great. So now so now we want to write down the value of OA divided by AD, 7.2. So we want to know OA divided by AD is equals to what, right? So we go back right here. So what is OA here? So OA, right? So let's look at first the bigger circle, right? So let's look at this circle, right? So OD, right? So OD is going to be your what? If we are looking at the bigger circle, AD is going to be what? The diameter of the entire bigger circle, right? So that means that OA is going to be what? It's going to be R, right? And the reason it's going to be R, it's going to be radius, because O is the center of the bigger circle, right? So that means that AD, right? AD is going to be 2R, right? So that means this is going to be R, and also this is going to be R, right? So here we are going to have R, and then this is also going to be R, right? So you have 2R. So therefore you're going to have your OA over AD, which is equal to, what is OA? OA is R, and then what is AD? It's going to be R plus R. So it's going to be R over 2R, right? So this can easily be written as your OA over, let's just write it on the other side. So now you are going to have your OA over AD, which is going to be 1 over 2, which is going to be the same as 0.5. All right. So now let's look at, it should be the last question, I think. Now let's look at the last question, which is question 8. Right, so now let's look at question 8, right? So in question 8, we are being told that in the figure AB is a diameter, as we can see here, of the circle. CD is a tangent of the circle at D, right? At D. CD is a tangent at the tangent of this circle at D. And then we are also being told that EC, which is EC, is parallel to C, is perpendicular to BC, and BAC and DE and BDE are straight lines. Great. So here we need to prove that ACED is a sidely quadrilateral, right? Remember that in order for us, so it's 8.1, in order for us to prove that something is a sidely quadrilateral, right? So for ACED to be a cyclic quad, right? The first one, we have to either show that the exterior angle, right? The exterior angle is equals to the interior opposite angle. Is gonna be equals to the interior opposite. It's gonna be equals to the interior opposite angle. So let's just write this neatly. Okay, let's just try to write this neatly. Yeah, now we can just write. So the first condition is that your exterior angle should be equals to the interior opposite angle. And then the second condition should be the opposite angles are supplementary, right? So the opposite angles are supplementary, right? So let's go ahead and try to do that, right? So we can either prove that both these conditions are true. So the first one is I'm going to look at D3, right? So D3 is going to be what? Is going to be equals to 90 degrees, right? So D3, so this is the angle I'm talking about. So D3, right? D3 is going to be equals to 90 degrees, right? Why? The reason is going to be angles on your semicircle, right? It's going to be your angles on a semicircle, right? Considering the fact that AB is a diameter, right? Which means that it divides this circle into 2 equal halves, right? And then already, if we know that your D3 is equals to 90 degrees, remember we also know that C, not C1, the entire of angle C1 is equals to 90 degrees, which is given, right? And then from here, if we know that D3 is equals to 90 degrees, D3 is equals to 90 degrees, it means that this one, we can also find it. So your D, the entire angle of D, right? So D is going to be equals to 180. Why? It's because of angles on straight line. It's going to be angles on straight line, right? So D is made up of your angle D1 plus angle D2 plus angle D3, right? So remember, we want D1 and D2, right, equals to 180 degrees. So your angle D1 plus your angle D2 is going to be equals to 180 minus D3. Remember, what is D3? D3 is equals to 90. So your D1 plus D2 is going to be 180 minus 90. And then now you have D1 plus D2 equals to 90 degrees. Right. So therefore, this now becomes easy, because if you have D1 plus D2 equals to 90 and C, which is C1 plus C2 equals to 90, then it means that both these angles are going to be supplementary, right? Because 90 plus 90 is equals to 180. Right, so therefore, if you check, your angle C, right, is gonna be equals to, right, let's just say your angle C plus D1 plus D2 is gonna be equals to 180 degrees, right? And therefore you can conclude that ACED is a cyclic quad, right? And the reason why we say this is a cyclic quad, it's because number one, your opposite angles are supplementary, right? And the other reason is that so let's just take this a little bit up. Great. So the other reason would be the exterior angle, your exterior angle, which is D3, is equals to C. So your exterior angle is equals to your interior opposite. Your exterior angle is equals to your interior opposite angle, right, which is both equals to 90, right? So this is how you solve the first one. So let's just go ahead and solve the second one now, which is 8.2. Right. So 8.2, what they are saying here is we need to solve, we need to prove that A2, which is this angle here, we need to prove that A2 is equals to D1, right? So this is equals to that, right? So the easiest way we are going to do this is very simple, right? So it's going to be 8.2. So we are going to let something be equals to x, right? Because eventually that will allow us to be able to solve this. So what we are going to do, we are going to say that your angle B equals to X, right? So this is the angle that we are talking about, right? It will become X, right? So if that angle is equals to X, remember your D2 is gonna be equals to B, which is gonna be equals to X, and your reason is going to be your tan chord, right? Your tan chord. This is what we are talking about here, right? So your D2 is going to be equals to B, right? Yeah, that's your D2. That's your D2. And then from there, remember we can find A2, right? So if we have this as equals to X and we have that as 90 degrees, it means that we can find A2, right? So your A2 is going to be 90 minus X, right? So your A2, so let's just do it like this. So your angle A2 plus your angle B plus your angle D3, it's gonna be equals to 180 degrees. Why? It's gonna be the sum of angles of triangle, right? It's sum of angles of a triangle. So what is no, should be A2. So what is A2? A2 is what we are looking for. So we are looking for A2 plus what is B? B is gonna be X, and then what is D3? D3 is gonna be 90 plus 90, which is 180 degrees. So your A2, it's gonna be 90 minus X, right? Because now when we transpose, it's gonna be 180 minus 90 minus X. So now we have A2, right? So now we have A2. So how can we find D1, right? How can we find D1? It's also fairly simple. Remember the entire of angle D, right? Angle D is equals to 180. Y, it's also sum of angles on a straight line, right? So angle D1, angle D, remember it's composed of D1 plus D2 plus D3. So it's going to be D1 plus D2 plus D3 equals to 108, right? So your D1 is what we are looking for, D1. We have D2, which is X, and then we also have D3, which is 90, and then we have also 180, right? So now remember we're looking for D1. D1, it's gonna be 90 minus X as well, right? So now if you look at here, we have D1, which is equals to 90 minus X. We also have A2, which is equals to 90 minus X, right? So therefore your A2 is gonna be equals to D1. Why? Because they are both equals to 90 minus X, right? So you can stop here, right? So now in order for us to do 8.3, so in 8.3 So what it's needed here is we need to prove that CDE is an isosceles triangle. CDE. So CDE, this is what they are talking about. CDE. Right. So there's two ways to prove that something is an isosceles triangle. Right. So the first one, so to prove that triangle CDE, right, is isosceles, right? The first condition would be let's use this one. So the first condition would be to prove that, okay, I don't know why it's not drawing the triangle properly. Let's try again. Okay. Yeah. And then we also have another one. And then we want to call this 2. So now the first condition in order for us to prove that something is an isosceles triangle means that both sides need to be equal. And then the other one is for both opposite angles to be equal. Okay. This is what we will need. Right. So now, in order for us to do that, let's see how we can do that. So that's gonna be very easy because remember we have D1. D1 is already given as 90 minus x, right? And we had already proven that also A2 is also equals to 90 minus x. And remember, A2 is an exterior angle of a cyclic quadrilateral, which is ACED. So it means that A2, it's gonna be equals to E, which is also gonna be equals to 90 minus x, right? So if they're both equals to 90 minus x, then it means that you have two angles that are equal, right? So now how we are going to do that is your A2 is going to be equals to E, right? So your A2 is going to be equals to E, which is going to be equals to 90 minus x, and your reason is going to be the exterior angle of cyclic quad, right? And then therefore we already know that D1 is equals to 90 minus x. We already know that D1 is equals to 90 minus x. Therefore, your angle E is equals to angle D1, which is equals to 90 minus x, 90 degrees. Therefore, triangle CDE is isosceles. Triangle CDE is isosceles. Triangle CDE is isosceles because two angles are equal. Right, so that brings us to the end of this question. Let's meet again on another series of iCamp lessons. Thank you.